Alright guys, in this video what I'm doing, as you can probably tell, I'm going to be going over some common mistakes that students tend to make when simplifying or verifying trig identities. So I'm going to end up color coding this, so you'll see like the first one I'm going to do in red here, so you can kind of see which topic I'm bringing up. But I do want to mention that just by the nature of the problems, I'm probably going to be mentioning some of these other concepts and other concepts I don't even have listed in here as I do these 4 problems. So that's like a bonus. So there's a lot of things to review, not just these 4 things that I have listed. What I would recommend you do as I go through these problems, as I set them up, go ahead and write the problem down. If you have to pause the video to do that, go right ahead. But we're going to move right into number 1, and I want to just, as I go through each one, I want to bring up these mistakes. As I bring these up, I'm going to let you know, hey, this is a mistake, so what I'm about to write is incorrect, but I just want you to be aware of it, and then I'm going to fix the issue. So on number 1, we're going to talk about how students, they don't divide fractions correctly. So to bring this topic up, I want to remind you the rule that we're bringing up in this problem, and that's when you divide a fraction by a fraction. So that's where we learned from middle school: keep, change, flip. Keep is where you keep the first fraction. Change is where you take that division and turn it into multiplication, and flip is where you multiply by the second fraction. Now the key is this: it's one fraction divided by one fraction. If it's 2 fractions divided by 1 fraction, or 2 fractions divided by 2 fractions, or whatever the case may be, we need to make sure we combine those fractions first. So again, notice 1 fraction, 1 fraction. So right now, I want to show you how what this mistake looks like. Is where we take our left-hand side. By the way, the first step I'm going to write correctly. It's the second step that's wrong. So you can write this first step. So we should start off with cosine divided by 1 over cosine plus sine x over cosine x. And this is the mistake that I don't want you writing down, where students kind of mess it up. So this would be where they go cosine x over 1 times cosine x over 1 plus cosine x over sine x. And they just flip right away. So this is going to be incorrect. Again, what we need to make sure we do first is we combine these. Right now I'm doing 1 fraction divided by 2 fractions, and I want 1 fraction divided by 1 fraction. So in order to get this fixed, what we're going to do first is we're going to combine these fractions. So we're going to have 1 plus sine x over cosine x. And now, because this 1 fraction bar is here, I have 1 fraction, which is basically cosine x over 1, divided by 1 fraction, which is this 1 plus sine over cosine. So I'm going to keep, change, flip here. So I'm going to have cosine x over 1 times cosine x divided by 1 plus sine x. Okay, so that means at this point what I can do is I can multiply across. So this is going to be cosine squared x over 1 plus sine x. Now, when you're trying to look at what we're trying to get here, you take a look at the right-hand side. I have a 1 minus sine x. So I'm going to take this cosine squared and use my Pythagorean identity. And that's going to be 1 minus sine squared x over 1 plus sine x. Now if you're wondering why I do that, first off, well, I got a cosine squared. Anytime you have something that's squared, that's a great time to use Pythagorean identity, but also look at your right hand side. It's in terms of sine. So anything we can do to get this in terms of sine is going to be a good idea. So now that I have this 1 minus sine squared, I'm going to now factor it. And this, I'll even put this off to the side. This is going to be this difference of squares factor, which gets used quite a bit actually, which is going to be a squared minus b squared equals a plus b times a minus b. So I'm going to do that right here. I'm going to go 1 plus sine x times 1 minus sine x, and that's going to be all over 1 plus sine x. And notice here, because of this factor cancels out on top and bottom, and we're left with our right hand side. So again, as I said, this is going to use some other rules as well, like factoring, and that is number 1. But again, I was talking about a couple things here. I'm talking about, 1, your difference of squares, but the main thing I was talking about is how to properly do keep, change, flip. All right, so next up, and I actually got to get this out of here. Okay, so next up what we have is number 2. I'm going to be talking about misusing Pythagorean identities. So again, I'll talk about how that gets done, and as I said, there's some bonus stuff we may see as we go through this problem. But here we go. On number 2, just again, here's some of the things that I sometimes see happen as you're doing problems like number 2. You're not using the correct Pythagorean identities when they pop up. Number 2 is a really quick solution, and it starts with this right-hand side. And the right-hand side, it's just, you need to pay attention when you see this tangent squared. That is a Pythagorean identity, and if you start looking at that and you recognize, and you'll see, hey, wait, tangent squared, that has secant in it. So if you remember this identity, and this is just one of them, but tangent squared theta plus 1 equals secant squared theta. This is something that's really important to know, because when you see tangent squared, you'd be like, oh wait, I can subtract 1 from both sides, and I know that tangent squared theta is secant squared theta minus 1. Again, when you're studying your Pythagorean identities, these just tend to fall off the wayside, and what I see a lot of students do is they change everything to sine and cosine, and makes it way worse. And here you can just go ahead right now, and you can just write this as secant squared theta minus 1 over secant theta minus 1. And once I do that, this is just like the last problem. We have another difference of squares. As I said, these pop up quite a bit. This is secant theta plus 1 and secant theta minus 1. Again, don't be so, used to just automatically changing everything to sine and cosine right away. Not when you can do Pythagorean identity first, because it's going to simplify a lot of stuff, because those secant theta minus 1s cancel. So now, at this point, yeah, I need to be in terms of cosine, so I'm going to change secant to cosine. So that's 1 over cosine theta plus 1 over 1, because I'm going to make that a fraction. And I'm going to get a common denominator. So now we're in terms of cosine, getting common denominators, things like that. So we now have 1 plus cosine theta over cosine theta. And again, you're trying to get that on the left-hand side, and we now have it. So we are good. Actually, I should just say equals the left-hand side. So again, don't freak, when you see a tangent squared, don't automatically make it sine squared over cosine squared. Or the same thing if you see a cotangent squared, or a secant squared, or a cosecant squared. Use your Pythagorean identities. Don't switch automatically to sine squared over cos squared or whatever. There's usually a much easier way to solve that. So again, that's a big mistake I see students make. Not that you're wrong if you change it to sine and cosine, but you're making things way worse. So that's number 2, not using your Pythagorean identities correctly. Number 3 is going to be misusing your Pythagorean identities. So that means, so number 2 is not using your Pythagorean identities when you could, and number 3 is when you use them when you shouldn't. So this kind of is the other kind of, the other way to look at this. Here's what happens on number 3, is students see 1 minus sine. They're like, you know what? 1 minus sine squared, I'll put this right off to the side too. So as we know, 1 minus sine squared theta is cos squared theta. However, 1 minus sine theta is not equal to cosine theta. And this is the same for all the Pythagorean identities. You can't just get rid of the squares. Here's a quick example. If I had a 3, 4, 5 right triangle, it's a Pythagorean theorem here. Yes, 3 squared plus 4 squared equals 5 squared. 9 plus 16 is 25. However, 3 plus 4 doesn't equal 5. So again, just please note, just because I see 1 minus sine, I cannot write that as cos u over cos u. Obviously, that's not, that's 1 and that's not 1, and maybe you would try to get that to equal 1 and maybe make some stuff up to make it happen, but it's not going to work. So we can't go that route. So what you do instead is you pick a side and you start simplifying it. Now, one thing you can do here is, and this is something I'm going to bring up on number 4, multiply by the conjugate. This is going to bring up my fourth topic anyway, because most people right now are not even thinking that. They're thinking, oh, I'm going to go to this side and change the sine and cosine, which is everyone's backup plan. Now, I'm not saying that's wrong, but again, a lot of times you're saving a lot of work, or sometimes it's almost impossible, not that it is, to solve it without doing this, but people kind of go the wrong route. Here, I just want to let you know, hey, you can multiply by the conjugate. Let's do it. So if you do that, this would be cosine u, and then this would be 1 plus sine u. Just kind of, if you multiplied those together, great. If not, I wouldn't do it yet. You'll see why. But this is going to be 1 minus sine squared u on bottom. Yet again, as I've been telling you on all these problems, that difference of squares keeps popping up. You see how this is a plus b, a minus b. So I wrote a squared minus b squared. Okay, now that is a Pythagorean identity. Not 1 minus sine equals cosine, but 1 minus sine squared does equal cosine squared. They have to be squared for this to work. So when I write my numerator, you'll see why I didn't multiply it out, because this is going to be cosine squared u. So that's going to cancel with that, and you now have 1 plus sine u over cosine u. So this, again, as I said, some topics kind of overlap, or some, when I'm trying to talk about one topic, another strategy pops up. This strategy I want to bring up right now is to split the fraction. Again, a lot of times people are just so compelled to jump to this side. We don't need to do that. Our strategies are still working here. I'm going to split this fraction up. This is my common denominator. So I'm going to go ahead and write this as 1 over cosine u plus sine u over cosine u. And that is going to be secant u plus tangent u, which is my right-hand side. Notice I didn't have to touch the right-hand side. I was able to get there using the strategies that we already have learned. So again, don't forget to multiply by conjugate. And also, again, as I was trying to bring up in this problem, understand this. You have to use your Pythagorean identities. You must have your terms squared. If they're not, then please don't use your Pythagorean identities. They're not an identity. Okay, so the last one here is come up here, and I already kind of did it, but I'm going to do it again with some secants, cosecants, and stuff like that. But people don't multiply by the conjugate. Again, I just showed that on number 3, but I'm going to show it one more time. And students don't multiply by the conjugate just way too often, and it's like screaming at them, please multiply by the conjugate, and you still don't do it. This would be a prime example where everyone's just, oh, let me change everything to sine and cosine. Again, there are other ways to do these problems. For example, multiply by the conjugate. And again, when you see a binomial and in the form a plus b or a minus b, which this is in the form a minus b, multiply by its conjugate. So that's going to be secant x plus tangent x, and secant x plus tangent x. So if I do that, left hand side, here I go, I'm going to have secant x, and then I have secant x plus tangent x. And again, I tend not to multiply that out unless until I am able to simplify everything and see if stuff cancels, and I can go ahead and do that. But down here I'm going to get secant squared x minus tangent squared x. Now again, this is where things overlap a little bit. Remember what we had up above here. Okay, we have our Pythagorean identities. Tangent squared theta plus 1 equals secant squared theta. Let's use them. Don't just change the sine and cosine. That's going to make things so much worse. Now I'm going to have to make all these fractions, get these common denominators. We're going to have to multiply my secant out, keep change flip. We're going to have to do all this stuff. Or you can save yourself a little bit of trouble. And as I said, Tangent squared theta plus 1 is secant squared theta. Let's use that to our advantage. Let's change that secant squared theta right here. Just tangent squared theta plus 1. So if I do that, I'm going to get secant x, and then I'm going to have secant x plus tangent x. Still not messing around with that right now. But my secant squared is tangent x, tangent squared x, plus 1. Notice how nice that is. The tangent squares are going to cancel. So we are sitting pretty right now. We have secant x, and then secant x plus tangent x. And look at that. That's my right-hand side. Notice how much work you saved by thinking outside the box, really inside the box. I mean, this is what we're really asking you to do anyway, is use your identities, and if you use it, it just takes care of itself. So again, don't be so compelled to change everything to sine and cosine. Use all your identities, especially those Pythagorean identities. Be aware of all of them, not just your sine squares and your cos squares, but your tangent squares, your secant squares. Anything that's squared, there's an identity that you can apply, so apply it. Please, please, please apply that identity. You'll be happy that you did. Okay, so make sure you're studying all those identities and be ready to use them all, not just your sine over cosine or your cosecants 1 over cosine. Don't just know the reciprocal and quotient identities. There are so many more that's going to come in really, really handy as you're solving these. Also, pay attention to, again, some of the strategies I applied about splitting the fraction, factoring, things like that. Difference of squares is one as well, which is factoring. But just pay attention to all those strategies. There's those little things that students tend to overlook, and hopefully this helped a little bit. So go ahead and get to studying, and hope this helped.